Hi everyone, welcome to today's episode of Quants Worth Following. Today we'll be talking to Professor David Lariviere. Professor David is currently a clinical professor at the University of Illinois Urbana-Champaign and is founder and director of FinTech Lab in the same university. Welcome, David. Would you be so kind to introduce yourself
Oh,
to
sure.
the
So as I
audience?
said, my name is Professor David Lariviere. I teach courses related to financial engineering, especially with an emphasis of ultra low latency trading and algorithmic trading. So I teach three main courses at the university, in addition to just semester-long student projects. I teach financial engineering, which is a generic overview of various financial contracts, things like options, stocks, bonds, futures, FX, crypto, you name it. But then the two main courses are IE 421, high frequency trading technology, and FIN 556, algorithmic market microstructure. So my ethos with teaching is I try not to emphasize having students memorize things, but really focus on having students build real world projects exactly like we would do in industry and really treat it more as like an internship or a preparation for work in the field and to allow students, one, to get real world exposure, but two, to see if they really want to work in the financial space to begin with, or maybe go work for big tech instead or AI.
Mhm. Yeah, I had the opportunity to take a look at some of the projects that your students develop, and it's very interesting that you're able to bring like very interesting projects that give them like the opportunity to get in touch with different aspects from the trading industry, from order book to trading to. I saw that one that is like a 3D visualization of the packets. It's very interesting. So I think it's very nice. Congratulations on your courses and your initiatives.
Oh, thank you very much.
And yeah, I would like to start asking about your career. Let's start from the beginning. Your career as a performance engineer and the trading industry, like how it started and how was your day-to-day job and what were your responsibilities?
Sure. So I got into the industry, depending how you count it. I was doing consulting for a company. I'm originally looking at doing private equity, sort of for doing Morningstar. But then I decided to move back to New York City and I decided to join an ultra high frequency trading firm. At the time, it was relatively small. It was GTS. They're relatively well known today. They're one of the three designated market makers on the New York Stock Exchange. So if you watch CNBC, a lot of the people walking around the New York NYSE trading floor, you'll see the GTS logo. I used to sit directly in front of their CEO, about 10 feet away. So I was initially hired as a senior software developer, initially put on a particular trading team that came in actually externally from one of the investment banks. So I was very fortunate to join the industry right around the time that the implementation of Dodd-Frank and in particular the Volcker rule was coming into play. So prior to about 2010-ish, the investment banks tended to dominate a lot of trading. But then in response to the global financial crisis, Congress passed Dodd-Frank, and part of that was the Volcker rule, which basically dictated that investment banks who had to be bailed out by taxpayers should not be engaged in proprietary trading. And so this was sort of a golden time in which you had many different, at the time, especially managing directors who were going from these very large investment banks down to prop trading firms with maybe only a few dozen people. And so I had the privilege of working actually with several of these, and then I learned a lot. So I started really as a software developer. I ended up sort of getting control of the futures trading code base, specifically targeting mostly CME. We were just building up our trading at the time on that exchange. Simultaneously, GTS, and there's a series of subsidiaries, but they had what was known as Strike Wireless, which was one of the subsidiaries, which was responsible for building one of the now famous microwave links connecting Illinois and New Jersey tri-state area. So one of the things that separated us from the majority of our competitors, though, is we actually leased that link. We made it available to other customers of CME and NASDAQ, and they commercialized it. I think later they sold the entity to one of the Canadian exchanges. But it was a wonderful experience. And one of the things I started doing with getting into the code, in addition to just understanding futures markets and a lot of the dynamics, understanding exchange connectivity, things like the FIX protocol, MDP, items like that. But it also was just a wonderful experience to then start digging into optimization. And so I got to do, for example, rewrite our decoders. I think I made it something like 20 times faster. That caught a lot of attention of the firm. And then so it also naturally progressed in addition to doing CME specific and future specific trading, also getting more and more into software optimization, but also just more broadly, all different types of next generation technology. So
Mhm.
things like overseeing the firm's transition from SVN to Git, going to things like automated taste testing, switching from software-based timestamps and packet capture to using passive taps with dedicated FPGA capture cards with pulse per second feeds from a GPS receiver. So it was really a wonderful experience. I learned an enormous amount. It was a massive amount of work compressed that I often was wearing the hats of, sometimes 5 or 10 different people compared to if you were at a larger firm where you'd have, I used to joke, but not joking, 5 or 10 dedicated teams of 5 people each. At a small prop firm, one person will be juggling all of that. So it was an enormous and very educational opportunity.
Yeah, I can see it's very diverse, and slowly you kind of feel into this performance optimization role, and probably something that you really like a lot. And one interesting thing is that larger trading firms, which can afford, they can have like a dedicated performance latency optimization team, while smaller firms, startups cannot afford that and have like ad hoc responsibility, where like people that like this kind of optimizations, they do by themselves. So the question is like, where do you think it's worth for a company to have like a dedicated team, and what are the advantages compared to having like ad hoc responsibilities?
Yeah, I think that's an excellent question. The very first thing that I think firms, and this really comes on to the PMs, the traders, or the partners of the firm, is you really need to understand what is it you're optimizing and to what extent is it expected to actually make any difference. And this is typically one of the most frustrating parts of our industry of you could theoretically spend $50 million, build a fully blown custom ASIC chip, thinking you're going to blow away the market, and then there's some other dynamic you're not aware of that's actually the determining factor. So maybe someone's getting a signal from a completely different market that your exchange isn't even looking at. Maybe there's some quirk or dynamic of the exchange's technology stack that your traders aren't aware of. So there's one that's, I'm not going to comment on it too much because I worked at the exchange involved, but it's very much in the public domain in various articles in the Wall Street Journal that a certain prominent exchange has a dynamic where traders who are actively part of a particular trade are sometimes notified earlier than the public market data feed that their particular order or orders were filled. And so this is a very classic example of something of you could take a public market database, let's say CME trading solution that goes from 2000 nanoseconds, bring it down to 2 nanoseconds, full-blown custom hardware, but that's still not going to win if you're competing against someone who may be writing code, very basically. In some cases, you can even do it in like basic C or C++ and just do it all in software, but they're leveraging private fills.
Yeah.
Right. Or similarly, depending on the size of the particular firm, one of the decisions that every firm that's very active in futures needs to make the decision about of are private fills only for the particular trading desk or team that's actually involved in those fills, or do you have a firm-wide ticker plant to disseminate that information? And so now here's another advantage of maybe it's not even just being the fastest or knowing about a particular quirk. You need to actually understand the dynamics of the market, and you need to be a certain percentage size, or you're just not going to be competitive statistically. And so this is one of the first things before we get into optimization of, will optimization even make a difference? And this is always the question we have in this space of, should I be faster or should I be smarter? And what's the potential P&L for doing one or the other, and what's the potential cost to do that? That said, in general, I think there are definitely advantages to having dedicated teams. The first step with this, though, typically is not optimization. It's actually instrumentation. So there's sort of this rite of passage for a lot of people in this space of, well, how do you benchmark the performance of a system? And often we start, I think all very simplistically, it's get time of day. Right? It's okay. When did I get the signal? How much time did I spend? And then you look at it and only do it internally that way. Then you start to see there may be issues with that. You switch to custom assembly instructions. It used to be a rite of passage. Everybody reads about the Intel assembly instructions with RDTSC and RDTSCP. Even just trying to measure time internally will actually impact the performance of the code itself. You have to do things like memory fences. But then it turns out if you really want to do this correctly, you start having to measure everything externally. And then it's, well, how do you even capture packets? How do you measure them? Do you look at UTC time? Do you look at sort of packet time, at the actual SerDes themselves? And then from there, once you have the data, then you can start looking at, well, what does it make sense to optimize and why? One of the other decisions, and this can be very difficult depending on how the firms are structured, traders are often, completely understandably, very nervous about telling developers exactly what it is they're doing. And so often this creates, and you may have experienced this firsthand, it's, well, we need it faster. Okay, well, what do you need faster? Everything. That doesn't help me much. And in reality, there may be this like one single esoteric case, potentially a single message that comes once a day per market. For example, the market open or some of these on magic packet trades that the trader actually cares about, or a very particular fill scenario. But then the poor developer could be wasting all of their time trying to optimize all these other cases that really aren't contributing to the alpha substantially. And so these are some of the questions you have to look at of how much infrastructure do you have, how much can you realistically and safely optimize, and then deploy this firm-wide potentially. Do you have dedicated teams that work just with particular developers? Do you have them focus on learning all of the tricks of how to optimize, or do you bring someone else in? And how do you find that balance? And I think different firms do this different ways. But again, it really comes down to first, one, to the extent it's even possible, can you first confirm that being faster and being a certain amount faster is actually what's going to make a material difference? And then two, you need to measure, well, how fast are you? Many firms I found are dramatically slower than they actually realize. Even more so, especially anyone who's done software, you have a lot of opportunities for tail latencies. Whether it's interrupts, cache misses, garbage collection, rebuilding of data structures, all of it, or even let's say a lock on the TCP stack. You may have multiple threads that are doing things. And if you're not segmenting, for example, with onload of different stacks, you could get deadlocks where you could have one thread or even the same thread talking to some back office system, and it needs to do a retransmit, and that's blocking much, much more critical path information. So, but I don't think there's any one single answer to this, but I would say in general, before going fast, make sure you have a sense that it's actually going to make a difference. Then two, always be able to measure how fast either you or the third-party vendor solutions that you may be deploying, and then you can sort of take it from there. This is one of the interesting things that I've noticed in the markets, which is I believe the only exchange I'm aware of to date that really allows you to do this is Eurex. So they offer something, and I may get this wrong, I think it's called the HPT or HPT, it's the high precision time service. So this is an end of day service where they're literally telling you to the nanosecond when every single customer who submitted an order, when is it first entering the exchange? Because often what happens, and most people I don't think are fully aware of this, on a single packet of, let's say, public market data, especially on markets where public data is first, often all these different trading firms are doing basically the same thing and using the same tech stack. So they all reply essentially instantaneously at the exact same time. And so what you can literally get are hundreds of individual packets all running in parallel down different fiber optic cables into the exchange. And so with this HPT, you're able to see that. Most other exchanges at best, you'll get a hardware timestamp after all of those packets get serialized and queued. And this is a big, big problem actually for quants, and ones I think this isn't as well known as it needs to be, of if you then see, okay, the winning packet had a timestamp of here, and then you see a series of other timestamps behind it in the public market data, you may assume, okay, well, as long as I was after this point, my order would have beat all these others. Well, in fact, there's 100, potentially 1,000 orders plus, all of which were submitted at the exact same time that you also had to beat, but you don't see that in the public market data. And so this is another thing that makes answering this question generally much more difficult, and hopefully more exchanges will catch on and begin to offer the service. But as far as I know, there hasn't been much movement on this yet, potentially out of concerns of what it may expose, et cetera. So.
And like having like a dedicated performance team, they can spend a lot of time like researching the market and exchange infrastructure and building these test environments that detect like a lot of nanosecond precision capture timestamp, and also maybe sometimes providing some feedback for software engineers that like I like the example that you said, like some maybe companies want to go, let's spend some money on FPGA or ASIC, but they still have a lot to catch up in software, so that it doesn't even make sense to go straight to hardware because they are far from that point yet. So I think performance optimization team can help in all of these aspects, and in fact to be able to help that and to help across different teams in the company, you need to have people that can spend their whole day, whole weeks researching these topics, and especially like maintaining this test infrastructure that is robust it's very hard.
100%. Testing these things right is extraordinarily difficult. I think this is one of the potential excitements about, we've already seen that crypto native firms and exchanges, they're already in the cloud.
Yeah.
But I think one of the hopes is as more and more firms, and we haven't seen how this played out yet, but there's been announcements with CME and Google Cloud, AWS and NASDAQ, of if these migrate to the cloud, you could see a day where instead of having to build all these mock exchanges and try to vaguely replicate their functionality and timing, imagine if you could spin up your own copy of the CME or NASDAQ infrastructure. And you can use that both for your performance testing, but also for your unit testing, your integration testing, your suite testing from a functional and safety point of view. And we're not there yet, but I think this could be very valuable for us as an industry as a whole, because this is a problem. We don't have a great way to really replicate and test things at production level, both for performance, but also on the safety point of view. And this has actually been a concern I've had for years. If you look at exchanges, and this is, maybe I shouldn't say this, but I will, exchanges do not have the ability to actually test their own infrastructure in a production manner because they don't have the scale of hardware necessary. Yeah. They would need the investment in custom hardware and just the number of links of all of their customers. And even if you were to try to ask all the customers to do it on, let's say, a Saturday, a lot of these trading strategy dynamics are not operating in a silo on a single exchange. They need cash equities open, Forex markets, other exchanges on other sides of the world. And unless you get all of that, it's very difficult to replicate. And hopefully going forward, we'll find better ways to do this, and the cloud may be one. Another thought also just on the performance optimization, and this is a big question of when we talk about the race to zero or reaching sort of a terminal state of HFT, I think performance optimization isn't just on the real-time day-to-day trading. What I suspect is going to become exponentially more important is not just who's the fastest, but who can come up with the best trading strategies at the lowest cost. And therefore, it's not just about real-time reaction to packet data, but how efficiently can you do backtesting? Can you do optimization, pruning? Can you do AI training, for example? And so I would not be surprised at all if you see a greater and greater emphasis, less on the real time and more on everybody has the same algorithms, everyone has access to ChatGPT and farms of GPUs. Who can get the most bang for the buck on that? And that's going to apply both for our very niche industry, but I strongly suspect more and more people from our space are going to be migrating into AI and going into firms like Meta or OpenAI or Anthropic, et cetera, especially where they're now offering up to $100 million pay packages. That suddenly moves the needle. And then it's like, okay, why am I trying to make, a 100th of a penny or something?
Yeah, it's going to be interesting. So going back to the latency part, so we have a lot of experience in latency optimization, and there's a lot of tricks that back then, like in 2010, when you started, that they were like completely new and not a lot of trading firms use it. But nowadays, most of these tricks, they are in public domain. So can you go over some of these techniques that you find interesting, especially those that are in public domain?
Sure, 100%. So there's some that are just, literally everyone knows them. The typical vendors hand them out. A lot of the different firms will be their latency optimization manual. So these are things like using tickless kernels, having dedicated threads, doing custom data structures, custom memory allocation, IRQ pinning, in some cases overclocking. In some cases, firms go the opposite route and actually turn off turbo boost because of the risk that it may go to 4.6 gigahertz and then drop down to 1.3 gigahertz. Also, you're getting lower level. Many firms obviously became very popular with using things like onload. It's very common then to start writing your own TCP stack, doing things in EFVI. Then firms start getting down to FPGAs. Once you do FPGAs, again, you start ripping out what's vendor provided. So often what they'll do is they'll implement their own MAC. Then you look, well, what's actually inside of the MAC? Well, you have a bunch of other logic doing things like packing counters and doing the field checksum, but then you're going to have what's typically what they call a PCS block, which is what goes from the 64 bits you want to send, and it does a scrambling because of the way electrically it's encoded. That's another common one that firms either now implement themselves, even if the FPGA vendor provides a hard IP core for doing PCS, or there are a collection of maybe about half a dozen companies that'll also sell you one of these. Then you can get into other tricks, things related to things like at the packet level. So there was one very cute one, and this was disclosed in a patent that I co-authored when I was at CME. Say there's a certain situation that may occur in the future where you want to submit 1, 10, 1,000 orders into the market. Think a simple example like, what if ES ticks up and then you will suddenly want to blast orders against a bunch of different components of the S&P 500. So what you can do is you have a continuous stream of data, typically in a TCP session, but you leave a gap at the very beginning, a minimum size Ethernet frame's worth of data, and then you post in all of the other traffic. And now that's sitting inside of the TCP stack at the gateway of the exchange you have. Now all you need to do to uncork that is submit a minimum size packet that plugs the gap, and then suddenly all of that becomes live and gets unrolled into the market. So I thought that was a very cute and interesting one. There was another one that I had speculated about. This is technologically possible. Hopefully I'm not giving anyone nefarious ideas, but the way Ethernet actually works compared to some traditional examples, there's a certain particular clock rate it's expected to run at, but there's a published IEEE margin for error. And then the real question is, what is the real margin for error? So how much can you actually essentially literally overclock the bit rate at which you're streaming things down a supposedly 10 gig link where it's still valid? One of the things that makes this even more interesting is there are some exchanges that offer 10 gig only links, but they may be connected to a 25 gig capable switch. So unlike 40 gig, which electrically is really 4 by 10 lanes, 25 gig SerDes, could they actually then, even though you start getting to things like PMA potentially, if it's depending on how it's turned on or off, could that actually handle a much faster bit rate? So those are some of the ones. There's one I haven't put in the public domain, though it is a concern. Everybody typically, when they talk about how do you get data between data centers, we're using microwave, millimeter wave, or if you're going across the oceans, potentially ham radio. But typically it's in the context of antennas, which are normally actually what essentially looks like satellite dishes on top of either the roofs of these data centers or towers adjacent. If you've ever been inside these data centers and you pulled out your cell phone or brought an FM radio, radio waves go through the walls. And so this leaves a very interesting question of what if you are the one firm, and remember, all the firms are supposed to have equidistant cabling approximately to the exchange, but what if you're the one firm that's closest to the wall on the perfect straightest path to another major data center, say that's giving you the price of the S&P 500 futures? This would then give you a systemic advantage, and you could pass it directly through the wall. Now, sometimes exchanges will play things related to you're not allowed to transmit. I don't even know legally if they can prevent you from receiving the data. And so this goes to an interesting question of, should all exchanges and colos be operated in true full Faraday cages? Right. There's other reasons potentially doing this for for more like safety and EMP hardening, who knows? But so those are a few cute ones.
Yeah, it's very interesting, and nowadays it's becoming narrower the number of techniques that only a few firms apply, because if you want to be in the top 3, for example, you need to do all the checklists before you go to the special ones, right? It doesn't matter if you are trying to do something very new, if you don't do the basics, if you don't do like the kernel bypass, if you don't do RRQ, if you don't do dedicated threads and number assignments, stuff like that.
No, 100%. And that's one of the things I both love. And I think a lot of people, it also goes to why this industry tends to be so secretive. If you just say, okay, imagine we have a list of tricks and 50% of the people do them, 50% of the people don't. And you do that times, 2 to the 32nd, suddenly 1 in 4 billion people will do all of the tricks. And it's very easy to do some of the enormously powerful tricks, but then you miss the completely low-hanging fruit. I remember instances, I was interviewing traders, this was years ago, and it would dig through, well, how much do they understand different dynamics? And it used to be the case on certain exchanges that you had what's often called the A feed and the B feed, 2 parallel networks for market dissemination, for high availability, no single point of failure. And often a dynamic you would see historically was the A feed was dramatically faster, potentially because the B feed could be coming out of a disaster recovery site. So it's going to be massively slower. This knowledge then sort of became ingrained. And then it turns out later the exchanges changed the way they do their architecture, their setup, geographically where things are located. Suddenly the B feed is faster 50% of the time by thousands of nanoseconds or more. So if you're spending all this time building this ultra low latency, nitrogen cooled custom ASIC, but then you're getting packets 50% of the time, 5 to 10 microseconds slower than your competitors, guess what? You lose. Right? And so there's this laundry list of tricks of how many different places do you look for sources of information. Locally, what are some of the other insights? Other strange ones that can be very useful. Even things like measuring the act times of the exchange, whether you're actively pinging or you're seeing when and how often they do a TCP ACK. All of these things can be indicative of what is the back pressure and level of queuing on a particular gateway or in a particular market segment. Something like that can give you an edge. Even more absurd cases, and this goes back to if you have dedicated optimizers, should they be a siloed team who doesn't understand the strategies or really be embedded with the traders? Sometimes, let's say you want to know a certain event happens, you don't even need to decode the exchange's protocol. All you literally need to do is look at what multicast channel is and the size of the packet.
Yeah.
I'm not joking. Depending on the exchange at the time, that alone tells you statistically what's in the packet. Just because there's very certain packet sizes for particular scenarios. And if it's a particular market, like, okay, it's a bunch of one lots, statistically, right? And you can get that immediately before you even get to the portion of the TCP payload. It hasn't even arrived photonically yet. And you already know with a certain probability what the nature of that packet is. And so it's very interesting. It's very fun. It could also be very frustrating because there is always this question of, is this really the best use of my time? Should I be investing enormous amounts of brain power and youth that I will now never get back looking at these quirky dynamics, or go work on some other problem that maybe has more important implications for society?
Yeah, it's an interesting discussion. But yeah, in one way or another, is pushing the state of the art. Like you need a lot of money, right? And the trading industry has a lot of money, and you're pushing the state of the art, and then these things like the military does so often, these technologies they come back to the societies somehow. So I also ask myself these questions like, yeah, I'm spending a lot of time trying to shape this for what? Like, what is the point? But in the end of the day, money to do research and this is not theoretical research, it's practical research, and then you need money to push the state of the art forward, and then eventually this knowledge will become public, and then other areas will use that, and yeah, I think maybe you can say to yourself like, yeah, it was not a wasted time.
Yeah, we were planning on talking about this, but this is actually an area that is extremely near and dear to my heart. And it's actually one of the primary reasons I've worked in academia while also working in the space on and off over the last 10, 15 years is for exactly what you just covered. I think a lot of the innovations, and many people in the space, honestly, you spend enough time, you get people with similar backgrounds, like you and I both done FPGAs, we've done DSP, we think a certain way about certain problems. Many of us all come to the same solution, but then it stayed siloed. So unlike virtually every other industry, we build a lot of enormous tech for our own trading, and most firms don't want to license that away, right? They want to use that to maintain their edge, and so it doesn't get out into the world. One of the reasons I teach is to look for other areas, other problems of society, completely unrelated in some cases to finance, that can benefit from what we're doing. So look at things like signal processing. Well, how do we make GPS more reliable? How do we get more accurate timestamping? How can we build better firewalls? How can we reduce the power consumption of serving petabytes of photos of cats? Right? This is one of always my pet peeves of academia. We love to work on these very cute, very smart sounding problems. What is the problem we actually care about? How do we serve JPEGs? And how do we do it more efficiently? Right. If you look at where the megawatts or gigawatts of power are going, albeit now a lot of it's going toward AI, which again, another perfect example of where it could benefit from a lot of the work we've done. How do you overclock the links? How do you make these more reliable? How do you carve out or eliminate unnecessary bits in the data? We can't do this with the exchanges as much, but a lot of firms will build their own proprietary SerDes protocols to link their own machines that are better than Ethernet. Because Ethernet's great, but there's a lot of overhead we just don't need, especially if you know these are point-to-point links and you know the nature of the data. And so looking at those instances of, well, how can we take what we as an industry have done and use this for other purposes? And I think that's a phenomenal area, and that's one that I would actually encourage a lot of people who already are in this space, especially if you're getting bored of this, think about national service. All right, think about things like cybersecurity. I sometimes joke with students, but I'm not joking. World War II took about 6 years. I'm worried World War III could be over in 6 milliseconds. And we all get a text message telling us who won. right? And so we need people who have our skill sets that are working on not just these problems. They are extraordinarily important in finance, but in other problems as well to better protect and safeguard society. And I think we have the skill sets to do it. So it's great training. I'll leave that much because it's much more competitive than most other industries.
But also, like, critique for the trading industry that is not particular trading industry. Like, if you have the ability to see what each trading firm is doing, you're going to see that the same piece of software hardware is being rewritten again and again and again. But I don't think this is particular to trading. It happens in trading maybe in a higher volume because of the amount of money that's put into, but in other areas as well. We both came from Harvard background, and also there's a fierce competition in EDA tools, for example. And between these two companies, there's a lot of things that are exactly the same. And yeah, it is competition, and that's how it works, you know. So what's interesting is that if you have the opportunity to work on different areas and then see how things work in one type of industry, another type of industry, maybe you can borrow some of ideas to other places. Like we do a lot in research. Like you see research to some area that is completely unrelated to what you're doing, and then you say, oh, maybe I can map this idea to the research that I'm doing. So it's like, I think we can, as an industry, not only in trading, but like a software industry, hardware industry, like do more of this, and then everyone benefits, you know.
100%. So I'll give an example of this. I was actually visiting Facebook's headquarters a few months ago in their timing lab, and there just happened to be a visiting professor, I think from Germany, working on robotics. And one of the things they were trying to do, I think, was things like real-time kinematics. But one of the things that was messing them up was the latency and in particular the jitter. If you're trying to say, okay, I want to do this sort of actualization given particular sensors, but you're getting noisy data coming in and highly non-deterministic ability to then actuate these physical systems. This is exactly the sort of problem our industry and technologists like you and I know how to solve. Another one I've actually been researching personally, CNCs, basically robotic drills that can be used to carve these very high precision parts. Again, jitter is a big concern. If you're doing something like a standard Linux-based system with Linux CNC, we know a lot of tricks to lock this down. It looks like some of them have found their way into this space. I saw recently they're integrating things like the real-time kernel, but some of the other more advanced ones like IRQ steering, also definitely doing things like FPGAs, with some of the commercial vendors already do, things like managing caches, making sure your clock speeds aren't bouncing around. All of these are areas that we take for granted we can do instantly, but we can deploy this to other areas. Even another simple one, like if you have a PDP time server, one of the projects I put students on for several semesters was basically building Raspberry Pi PDP NTP Grandmasters. And again, you have a similar issue, but if you don't have a PDP-enabled NIC, you can still at least lock down the determinism of being able to ingress and reply with different timing packets, and therefore improve timing for everyone. So I just think there's a massive number of potential use cases for what we've developed in our small little niche that it needs to, and it already is starting to, I think, bleed out through the world. There was another great example. I think it was the tickless kernel patch. I don't know this firsthand. It was relayed to me by a friend, but I think he claimed that the person who did that at the time was at Jump Trading. And even though this arguably could have been secret sauce and was kept internal, my vague understanding is this was decided they did open source this. And so this was something that had potential enormous benefits for every computing device on Earth, anybody with a cell phone running Android. And so it is just an example of what is possible.
Yeah, yeah, definitely. Cool. So let us talk about a bit of your experience with CME. So particularly the market segment gateway consulting that you have done. And can you talk a bit about it and how it compares to the convenience gateway that it used to be?
Perfect. Yeah. So as I mentioned, when I joined GTS, I started working on trading strategies, focused with some of these teams that were doing CME and future-specific trading strategies. And of course, I'm there. One of the reasons I joined is I wanted to work on making things faster. And if you make things faster, you win. And then I start analyzing these raw passive tap packet captures, and I start seeing things like, wait a minute, I'm sending different packets, and this packet was sent 50,000 nanoseconds slower than another packet, but it's getting into the matching engine first. And so this, along with a lot of other analytics, just looking at the public market data, it became very clear that one of the determining factors, and it wasn't necessarily even static, it was dynamic based on everything else that was going on at the time, is depending on which gateway you individually had a TCP connection to that was processing your orders, that had a massive impact on in what order your packets relative relative to others came in. So in other words, at a network level, it was not truly FIFO. And I want to be clear, this is a problem that exists on basically every exchange on earth to some degree.
Trading companies could do like a gateway arbitrage across different.
Exactly.
Yeah.
And this has been in the public domain for at least 12 years. There's very few academic papers I tend to refer my students to. One of the ones I do love, though, is called Barbarians at the Gateway. It was published, ironically, by another former high-frequency trader, and they call out exactly this dynamic, right, of gateway arbitrage being one of the things. And you can basically think of this like, imagine you have 50 different highways all going in parallel to the same next city. Well, different ones are going to have different levels of traffic and therefore different queuing. And it's not constant. It changes real time. And so this I kept seeing, and then I kept calling them up and going, what's going on? What's going on? But also we developed a great relationship with them. We, at the time, where I wasn't directly involved with this, minus the data feed handler, but we were also building the wireless network with them. And so more and more the relationship grew. And so they basically offered me the opportunity of, well, if you don't like it, come help fix it. And so I had the privilege to be able to go there and help oversee this deployment of what was, I think at the time, an extremely novel change for an exchange that was that important and that large, of rather than having many different gateways, which customers would be assigned to one or potentially some subset for a particular market, whether that's equity futures, precious metals, energy, fixed income, you name it, there will be a single gateway, thus the term market segment gateway, that all traders could have TCP connections to. And they coupled this with some changes in the hardware and software stack so that the software gateway would get packets and process them in the order they actually received coming into the wire. Yeah. So if you took a passive tap of the 10 gig link going into that machine, whichever packet was there first is the one, assuming it was complete and there weren't gaps in the TCP frames, et cetera, that's the one that then enters the market. I often joke that project took 3 years of my life. It probably took 10 years off my lifespan. I'm probably not joking on that. Because, I mean, there you're dealing with a system that processes notionally more than $1 quadrillion a year. Right. Yeah. If there's a mistake, it could instantly crash the U.S. stock market or countless other markets. And when you're working at trading firms, you don't fully appreciate that. You're worried about doing something stupid. You're worried about getting in trouble. You're worried about hurting your own desk P&L. You're worried about potentially blowing up the firm if someone pulls a night capital. But it's relatively rare, hopefully, where it is that systemic. Where there, it gives you sort of a different sense of responsibility and honestly fear about what you're doing. And that's something I was very privileged to be a part of. I'm honored that I had the opportunity to work on that. And it looks like it ended up in the long term to be actually a great success. So after that successfully deployed, Eurex later essentially copied that model. And then I think they've continued to enhance it since and improve it.
Yeah, it's a great experience. It's an amazing opportunity. And congratulations for making it happen, because it's a lot of work. And yeah, like you said, 3 years, but virtually 10 years to complete that. And probably you were working like over the weekends and
like 3 a.m. calls with people in Singapore. It's like something's going wrong. Okay, something's going wrong yet, but I'm seeing a gauge I set up and it's going yellow. Why is it going yellow? We don't know. Okay, we need to find out before it goes red. So it was very interesting. But one of the other, I think, great parts of that project for me, but I was very responsible with it, I had access to every single trading firm's packets. I could see them all coming in. This is also why when I finished that project, I did not go back into the industry for a while. Basically, I felt I knew too much. So and I didn't want to worry about anyone coming after me. But it gave you insights to see a world that I think extremely few people have, where either you have people who work at the exchanges and they see everything, but they don't have the experience in the trading firm to necessarily understand what they're seeing, or your people at the trading firms who may get to see, even in their case, a tiny fraction of what their firm is doing or their desk is doing. It's rare to be able to work on both sides, understand what you're seeing and seeing it all. And so that gave me some enormous insights. And then some of that also then bled into some of the packets we ended up filing of how to protect markets. And then those weren't just for CME. Later, I think other exchanges adopted some of those. And some of those were premised on behavior, maybe, that was observed, though I'm not saying that is the case. In other cases, it was pure speculation if somebody could do this, including speculative messaging. But later that's got into the public domain, and that's sort of another benefit of this, of then providing the ability of, okay, here are all the different things people can do. How do we as an industry address this? Do we allow firms to corrupt packets or not? Do we instead give them an ability to redirect it? How often can they corrupt it? In what manner are they allowed to corrupt it? What are the downsides of offering that? Right? In some cases, if you block one avenue, they may just find another, and that could have more negative repercussions on the markets. And these aren't always black and white or easy or obvious questions. It's something we as an industry, I think, have to debate even more. The problem is most of this happens in silos. It's not in the public domain, and so it's difficult to have free discussions about. But hopefully we're slowly inching those discussions forward. That's another reason why I'm thrilled, by the way, that Databento offers PCAPs. A lot of the other data vendors don't do that. Right. Typically, it's normalized. You don't know where they're capturing it, how they're capturing it, what's being discarded, et cetera. And just that is the lifeblood of trading data. And trying to get the access to that, one, to people in industry, but I think especially academics, to see this is the raw data that high-frequency traders are using with the exact nanosecond timestamps. That's an enormous public good that I think in the years to come, we're going to see more and more interesting research in the public domain rather than just being siloed at this handful of firms who really fully understand this. So I look forward to seeing that. I think you guys are helping to facilitate that in a great way. So thank you for that, seriously.
Yeah, thank you. And I would like to ask about the career advice. So if someone is willing to build background and intuition as a trading performance engineer, it requires first a very good understanding of software and hardware optimization that is generic, but also a lot of market and exchange infrastructure, which is kind of hard to get. So what is your advice for someone that is willing to transition into this role?
So the first thing I would say is think very strongly, why is it you actually want to go into this space, right? And so I always have students who get this. Sometimes it's adorable. You'll have like a 17-year-old, and they'll be like, I really want to be an investment banker, right? Or I really want to be a Delta One trader, right? Or this or that. And I'm like, I don't think you actually do. I think you just want to make a lot of money. Come on, fess up. And they're like, okay, yeah, all right. And so that's always the first question. What is it that really motivates you about this space? And are there better spaces where you can potentially get paid more, have lower risk, and work on more interesting problems? So that would be the first thing. So right now, I would say if someone does have the skills to be in this space, if I were a smart, energetic, bright, let's say 20, 22, 24-year-old, I would actually strongly consider, again, looking at AI. I think the amount of CapEx we're looking at spending, we're talking about $1 trillion potentially building these massive data centers. If you can save even one of these firms 50%, 10%, even 1% on power, that is dramatically worth more than I think a lot of our industry is going to make cumulatively. So that'd be the first thing, right? And the skills you develop there are much more transferable. That said, if you're looking at what are great ways to understand this space, there are a few books that are really good. One in particular I liked, and I was shocked at how good it was. It's called Trading at the Speed of Light. That's a great overview of the industry. Obviously, and I'm not trying to hype you guys, you really do, Christina and others do a phenomenal job of covering this with your market microstructure posts on LinkedIn. They're some of the best ones I read, and they run very in parallel in many cases with things I cover verbatim in my classes. Another one I would strongly recommend is just follow various people on Twitter and LinkedIn and see what they're talking about. And very quickly, you can start to identify the patterns. Also look at things like the various vendors in this space. So I would start by going to Stack Research's website. That's sort of a who's who of the technology firms that sell to the space traditionally. And a lot of those vendors go through their products, go through their tuning guides to the extent that they put them in the public domain. Those are all excellent resources. Another one, if you're trying to understand market microstructure in particular, there's two sets and they're both government related. Often when an HFT firm makes a mistake, let's say they're violating some rule or they had some technical issue or bug, there is a deep dive post-mortem that goes in the public domain. Those reveal an enormous amount about the intricacies of sometimes both the trading strategies, the technology stack, and even the organizational structure of the firms. Things that you will almost never see in writing in the public domain otherwise. There were some great ones, for example, that I think there was a case, not to pick on them because I admire the firm enormously, but I think it was Tower Research who got in trouble for violating what's known as the protected quote. This is essentially where if one exchange has a tighter bid-ask spread, or let's just say a better offer, and then you are legally obligated to try to hit that quote before you hit liquidity on another market that may be quoted at a worse price. For reasons that actually sounded understandable given the post-mortem, they had some glitches where this wasn't being adhered to, but I think it was the SEC or DOJ complaint explaining this in minute detail was phenomenal. Another one related to that, this is when firms in this space fight, look at both lawsuit complaints, but also SEC comment letters. So one set of these that our industry has been laser focused on in the last year is the back and forth between McKay Brothers, who's one of the definitive microwave millimeter wave data center connectivity firms, versus NASDAQ. And this has to do with NASDAQ building out what's known as the NY11-4 complex. And so this gives a lot of details and often very concrete numbers. And you can also see how different firms, one, both view the same discussion, issue, phenomenon, problem. What's a great product innovation from one firm's perspective is a horrific violation of the Securities Exchange Commission's obligations under federal law to another firm who may be losing money as a result of that change. And so getting all of these and seeing them together, I think, is very useful. So another one I sometimes try to get students to look at is to go through from first principles rather than someone telling you and ask, why does this thing exist? Why does this product exist? Why does this order type exist? Why does this order modifier exist? Why does a particular exchange exist? Why do we have inverted fee structures where you actually pay to market make, but you get paid to remove liquidity? Right? Why do you have a post-only order type? Why did IEX introduce DPEG or the crumbling quote? Right? Why did Citadel sue the SEC over allowing that? What are the different dynamics at play? So I think there's a similar debate going on right now in the options side of things. And there have been, again, different players will talk their own book and talk about why they think something is bad or good, try to take in both sides, understand the financial incentives involved, but read what's going on. And often, ironically, those enforcement actions or legal or regulatory disputes are one of the few cases where you get a gold mine of information in this space. Another one in some cases you can look at are things like patents. Those are interesting as well. But a lot of the best tends to be the informal things. You'll find things that are gold mines sometimes on Reddit, on individual blogs. Often, eventually, though, those people will then go back into industry and then they scrub everything. So then you have to check the Internet Archive website. But there is a lot of enormous information out there. There's very few textbooks, though, especially at the nitty-gritty level. And one of the reasons for that is this industry is constantly evolving so quickly. By the time you write a book, it's already out of date, right? And that's if you even just cover a single market, let alone the full breadth and the full ecosystem of it.
Yeah, it's definitely not easy to get into it. And that's why the first thing that you said, like, think before why you want to get into this space, because it requires like a tremendous amount of effort and dedication before, like, to pass through an interview and get into a trading firm to work in this area. And then while being there, once you were like performance engineer at a specific firm, you need to constantly like look for new information, and it requires a lot of effort. So it's important that you like and you know why you're doing that. Right?
100%. And related to that as well, one of the other things I try to warn students is, even if you do want to get into this space, do not go for the most competitive jobs that every math Olympian on earth with an IQ over 180 is also going for. Try to go for the back door, right? Go for operations. Go for DevOps, go for testing, go for UI design, go for the person who fetches the trader making $100 million a year coffee. And then say, in between coffee runs, can I work on some Python data analytics? Sure. Right? That's the way to go. Everybody's trying to go to these ultra competitive specific roles. And well, first lesson in economics, there is a massive supply of talent that wants to go in here. So what does that mean? A few things. One, you're driving down wages. And two, your probability of getting in is going to be exponentially lower. This sounds like a poor trade.
Indeed, indeed. And being there in a different role also gives you exposure to the area, and then you can learn a lot of different things that you wouldn't learn otherwise if you were out. And then being there and showing that you were hands-on and you were capable of getting different responsibilities, then maybe go to the position that you were initially aiming for.
100%.
Probably you're not sure that you like it, because if you don't like it, then you will drop before you even try to get into there.
Exactly. And just thinking out loud, and some of this is what I've observed with students and just other very interested, bright minds throughout the world. One of the massive changes that has happened in the last 5 or 10 years is the evolution of crypto and DeFi in democratizing access to algorithmic trading.
Yeah.
And so what used to be where you needed a 10 or $100 million IT footprint and be a registered broker dealer and have all this other stuff in place, which to trade something like cash equities, maybe you do. In crypto, it doesn't matter as much. Nanoseconds do not matter in most crypto markets. And the reason for that is you don't even have multicast. So every trader is being told about the state of the order book or individual trades at dramatically different jumbled times. And so what this actually essentially acts as is like a Gaussian blur on the marginal value or even perception of latency. Also, you can get started with very little money. Now, if you're a U.S. citizen, you have to be very careful. I don't know what the state of the regulatory environment is now in the United States with the new administration, though it seems much more crypto friendly. But for many students or many people who aren't students, if you're just looking for a way to get into this space, that could be a great way to do it. You could set up your own AWS instance in, let's say, one of the Tokyo AWS zones and start recording your own market data from some of these major exchanges. And that gives you experience on that aspect. Then you can build your own connectivity. They have test environments. Then you can start working on building your own simple back tester, building your own order execution algorithm, and start from there. And if you're really serious about getting into the space, if you do all of this adhering to best practices, even if you make absolutely no money, that is a phenomenal resume item that many of the candidates are not going to have, and it completely sets you apart. So often I think students, and not just students, people in other industries want to get into this space, they sometimes tend to focus too much on what they can memorize, not what they've done. So one of my favorite interview questions I used to love asking people is, tell me everything you've done in the tech side of things that you were not paid to do and you were not doing for a degree. That's how you identify the rock stars generally. And they're people like me who in some cases maybe aren't fully mentally healthy, right? It's like, why do I do this? I can't not do this. Why are there passive taps and fiber optic cables all over your living room? Wait, your living room doesn't look like that, right? It's so you need people who just have that bug. They just have to do this, right? And you just keep going down the rabbit hole, making things faster, more accurate timestamps, everything. It's almost comical, if not sad, but those are the people often who tend to succeed in this space. But prior to when I was getting in 10 years ago, you couldn't do this. Vast majority of the broker dealers then did not even have APIs, in part because it made payment for order flow less valuable. You know, you may have an IBKR, but in general, you had to be a hedge fund if you wanted even just basic algorithmic access, 15, 20 years ago. Now anybody can get it on crypto and a lot of other markets. You even have things like sports betting markets. Now we have the legalization of these event markets that seem to be growing in value, and also again societal value of being able to provide real world monetary insight into the relative probabilities of events instead of just randomly polling or asking experts. And so these provide, I think, a lot of potential advantages. It is an enormously exciting time. That said, is this really the most important thing to be working on, either from a societal point of view or from a P&L point of view? I don't think so. My guess, my strong hunch, it is AI, and it is the race to AGI. And whoever gets there first, they're going to get everything, including everything we just talked about. It'll be left as an exercise for the reader, where in this case, the reader is an AGI. So, this is always the interesting question of how do we allocate what remaining time we have on Earth? I don't know the answer for sure, but I expect it's going to be more some combination of that and maybe quantum computing. Although that's another one that's always 5 years out, but it looks like maybe it may actually be 5 years out. So, but I will say this to younger people watching this, there has never been a more exciting time to be alive or to be a technologist or a scientist. So, but also try different things. One of the reasons I do my courses the way they do, I want students to experience it. And sometimes I actually make it intentionally tough, where you compress it and say you have 2 months to do this, where then the first 2 months they're just sort of learning things. And then it's very, very tight deadlines. I want them to understand that. And how do you juggle all these different things and how stressful it can be and how overloaded it can be. And typically they don't get that experience either in academia or even in many other jobs. Our space is truly unique. I can't think of any other industry on earth that is as competitive, where you can be the best in the world and 24 hours later, you are done.
And then they can have like this controlled environment where they can have the experience of high pressure that they can eventually have if they get into the industry. So it's
exactly. But it's great preparation, because I always tell them the best way to do an interview is not to answer a bunch of brain teasers. It is to show the interviewer verbatim what you've done that is exactly what they want to hire you to do for a job.
Exactly.
Because you could interview someone for a week or even a month. You still don't have a great idea how they will actually perform in the role.
Yeah, and
right?
there's
And
a
this
lot
is
of like
why
team
now.
dynamics that you don't understand and you will not understand until like have the person in the team, right?
Exactly. And that's the other reason I typically tend to insist on teams. It's very different doing problem sets solo compared to when you need to work with a group of people, including a group of people with different time constraints, but also very different disciplines. Because so many students at our university are interested in this space, I get students from 20, 25 different majors sometimes per semester.
Mm-hmm.
I mean, every aspect of STEM and then many others. The majority are CS plus something, computer engineering, electrical engineering, but physics, aerospace, nuclear, material science, you name it,
Mm-hmm.
right? And trying to get that group of people together with different skill sets and how they can be greater than just the raw sum is, I think it's one of the phenomenal things when it works in our industry that you've seen. I imagine you probably experienced similar things. You deal with countless brilliant people with completely different backgrounds.
Yeah.
Right, physicists, mechanical engineers, aerospace, you name it. You get those different experiences, areas, types of mathematics, et cetera. And then how can we take from the best of all of those and combine those to achieve some collective mission?
Yeah. Yeah, indeed. And before we finalize, I wanted to ask you a bit about, because you were talking about the students, the classes, and stuff like that. I wanted to understand better about the origins of the FinTech Lab. You founded and you were director. What motivated you? What are your goals? I think you touched a bit on some of these aspects, but yeah, it would be nice to understand the rationale behind creating this lab. What's your mission?
Yep, 100%. So before I got involved with U of I, when I was first getting into the space as well, I had returned back, and I originally returned just as a volunteer, not even as a professor at my alma mater. And I was training students in mostly ECE, so electrical engineers, computer engineers, some computer scientists, in the embedded systems course, which teaches FPGAs and hardware software co-design. So how do you build a custom hardware accelerator? How do you write software that can interact with it? In some cases, even Linux drivers to sort of build these full systems. One of the motivations for that at the time was you had many students that were interested in jobs, especially in the New York City area, in electrical engineering. There are very few jobs in Manhattan that require electrical engineers. Typically, it doesn't make sense. One area that seemed very natural was financial services. And this was at the very early stages of people using FPGAs in the financial services space. So there, I actually did have physical lab space inside the CS department. And actually, SolarFlare was generous enough to donate 2 of their very first FPGA boards at the time. These were based on the Altera Stratix 5s. And so we had a physical lab and students doing custom hardware. Later, when I started first flying to Chicago and then later moved here full time, which I've been since 2015, I was more affiliated with the University of Illinois, initially while working at CME doing these practicums. And there I was mostly training quants. And so for a lot of the projects we had been doing then, them having their laptops was a sufficient amount of computing resources to do things. Then in 2019, we were very fortunate that a company called RCMX actually donated to us licenses for their commercial HFT grade backtesting software. So now I have students writing C++ based trading strategies with a backtesting engine that understands things like maker taker, can do latency offsets, will do the full order book construction, all of it. And so that was phenomenal. And at the time, I standardized on x86 with VirtualBox Linux machines, and it worked whether someone had Windows, Mac, or Linux. What really started changing things was around 2020. We saw the introduction, or 2019, of the ARM-based Macs, and MacBooks are very popular, especially with students. That basically broke my curriculum. In addition to that, we started getting more and more market data. So initially, the only sort of primary source of market data we had was from IEX because they post the PCAPs at the end of every day. And this started growing in size. And very few students, some you'll be surprised, even sometimes have tens of gigabytes of storage space free, let alone hundreds of gigabytes or terabytes of data. And then as you get more data, you also need more memory, you need more computational power. And so it became more and more clear that I needed to get some sort of physical computing that I could provide the students access to run this specialized commercial software. So around the same time, one of my friends approached me. He had a series of spare HFT grade at the time, about a decade ago, were bleeding edge machines. These were actually, I think, clock to stack is like the fastest ever and one of the tick to trade benchmarks, dual Xeons with solar flare cards. So I set those up. Originally, they were in the middle of my living room. I do not recommend having a bunch of HFT grade servers in the middle of your living room. It gets very loud very, very quickly. And so that really represented the origins of the FinTech lab. But really, it was this desire to get students access to industry grade hardware. So they're not just doing things in Pandas or Jupyter notebooks on a laptop with maybe 16 gigs of RAM. You give them access to the big iron, right, where you're talking about close to a terabyte of RAM, hundreds of terabytes, potentially petabytes, which I'm hoping to get to, of storage space to have massive amounts of data. Also running parallel to this, I had stopped teaching custom hardware design for a while, and one of the reasons for this was a lot of trading firms about 10 years ago started going full-blown ASIC route. So not just FPGAs, but actually doing their own. That's outside my wheelhouse. I'm more of a digital logic person on the software stack, minus if you get into things like radios. And so because of that, I stopped teaching this for a while. About a year and a half ago, Xilinx, I guess now AMD, introduced a custom FPGA, and they reduced the latency by a factor of 7. So suddenly now I think it's 2.6 nanoseconds. You can do round trip. Suddenly FPGAs are competitive again. So now is another reason to have a physical lab space where we can start working on building custom hardware for things like trading, but also other ultra low latency applications like cybersecurity, and another one I'm enormously excited for, ultra low latency artificial intelligence. So there are now a line of FPGAs that have dedicated ASIC IP core blocks that are specifically for doing inference on things like the Versal line. But also you can use the generic programmable logic fabric to also implement custom inference. And you can do things in ways you can't do in a GPU, because you can literally, for example, hard code the weights in the fabric itself. It can be extraordinarily powerful, the types of shortcuts you can do. You can arbitrarily choose in some cases what precision you want to do. You want to use 8 bits? Great. 4? Great. 3? Sure. 3.5, not sure how that would work, but and so you combine all this together, it gets very, very exciting. And then one other motivation that I've seen just more and more following what the academics do, many academics in this space do not understand or have a full picture, unless they've also worked in industry, of the differences between the academic level of market microstructure and analytics versus what we do in the real world that you and I have seen firsthand. And part of that is an understanding issue. I think a bigger part of it in many cases, they know there are gaps, they just don't have the resources. And does it make sense for every single researcher around the United States to individually try to set up some massive GPU farm or massive SAN with hundreds of terabytes or petabytes of data? I don't think so. And so what I'm hoping for longer term as I continue to build this out is to create a single center where we can allow academics from around the country, and if the exchanges and vendors who give us the academic fee waivers allow it, even internationally, to have a single point of best practices, DevOps scripts to configure their own servers if they want, but also access to these resources so that they can better model and understand financial markets across the globe in the same level or even approximately close level as you would see at a major prop firm or even many investment banks. And so that really is the motivation and target long-term trajectory for the FinTech Lab. In addition to also, as we mentioned previously, what are other uses completely outside of finance where we can use this extraordinary know-how and performance, whether that's reducing the power consumption of AI data centers or being able to protect against spoofing from airplane signals. So what is the real-time location of aircraft, or what is the probability they may suddenly collide? Right? There's an enormous wheelhouse of understanding and know-how that we take for granted because we do it every day. But I think it has enormous potential positive benefits, just like you mentioned we've seen in the last 100 years with the defense space. Right? Most of the technology we have today is one way or another connected historically to the military-industrial complex. And that yielded enormous dividends for the rest of society in a civilian and peacetime capacity. I think a lot of what we've done in HFT holds similar promise. We just need to connect the dots and let other people know for those things that aren't secret sauce that we're willing to share and we all take for granted. go to other researchers in other spaces and say, hey, maybe you can use this for your robotics project. Maybe you can use this for your data science project. Maybe you're looking for coming up with new models of drug discovery. We have tricks that could accelerate that 100x or reduce your power budget, right? All of these could have enormous positive externalities in society. We just need to, I think, start making those connections. But it is starting to bleed out more and more. And you're seeing more and more former traders and trading firms where they pivot and go into other, sometimes adjacent or maybe completely different areas. But I'm very, very excited to see what the future holds. But I think the biggest question now is who's going to get to AGI first and what are they going to do with it? So, and we'll see how that plays out, but some of the people listening to this, they may end up getting affiliated with that and be the determining factor. So I'm very excited to see what the future holds.
Yeah, I really like this idea that you started with one goal in mind and apply to financial space trading industry, but then you can potentially fan out the lab, the infrastructure, the know-how to different areas. And this is really great because, like you said, it's very hard for researchers in the US or even, let's say, in other countries to be exposed to such infrastructure and know-how. So this is a great mission, and I think it's a nice ambition that you have in a mid-long term to build this infrastructure and have the know-how to span across different areas. And I think this is really noble and great. Congratulations on that. Nice.
No, well, thank you. And I seriously owe a profound thank you to Databento. One of the single most difficult parts of doing all of this is the data. Yeah. So I have a commercial back tester. If you put a gun to my head, I could build one from scratch if I needed to. What I can't build from scratch is the actual market data and the actual nanosecond timestamp PCAPs at scale that I would actually need to do this. And this was one of the other things that kept me from doing this for so many years, of even if I built all this other infrastructure to do the market analytics, unless you have accurate data, not just some vendor provided, scrubbed, completely arbitrary, God knows how noisy timestamp data, but something you actually trust, this is a fool's errand. And so honestly, one of the enabling factors was when I found out what you were doing, that's what really said, aha, now I can start putting all of these other pieces together in a much more realistic way. So similar to you asked, how can people get a better understanding of market microstructure? I'm extremely excited for the types of trading strategies my students are going to be able to start doing in subsequent semesters, because now it's not just IEX or IEX plus maybe public crypto data. Now we can look at NASDAQ and IEX, or NASDAQ IEX and CME, even combined with Eurex and a lot of the other markets you keep bringing on board, even Oprah with options data. I used to always forbid my students from doing projects on options. And one of the reasons was like, okay, can you get the data? If you want to get Oprah, let me know where you're going to put it, because I don't think you're going to get Oprah. Now we can actually get Oprah and do some of these things. And they were some of the most interesting studies, and some of the ones that are most heavily covered by academia, going back years with things like, for example, the VIX. But to do that, you need an enormous amount of data to do it. And so finally we have a vendor where I think there's a clean path where I can get it in a format that's trusted and vetted, and I can write the parsers myself so I know nothing's getting lost or obfuscated or mis-timestamped. People take for granted, they assume there's one timestamp on an event. There isn't. There's sometimes dozens. And the only way you can even see that is you get the raw data, and the raw data plus the PCAPs. Many of the exchanges, when they sell you the data, even they don't give you the PCAP timestamps. They're like, oh, well, this is the timestamp. No, that's the software timestamp of your ticker plant. It tells me nothing about when the market found it out. And so, again, I just, to you, your team, Christina, Luca, and everyone else, thank you, thank you, thank you. I am extremely excited for what the future holds. And a lot of that is being enabled by finally getting access to the data. So thank you very much.
Yeah, we are happy that we can facilitate this research and fill this gap that, just as you described, is like impossible to achieve, even though you could build a backtester from scratch, but if you don't have the data, it serves nothing, right? And I hope that we can continue expanding to other venues, other countries, so that we can give even more ability for your FinTech lab to do even more research on trading strategies and different markets that are now like restricted to only IEX and crypto. And like you said, in the forthcoming semester is going to be expanded to other markets. And that's great stuff. Yeah. We certainly are going to have much more to talk in the future.
Oh, definitely. And there's one last thing I'm morally obligated to ask, both for Databento and also anybody else watching this. If you are interested in hiring fresh talent, my students are brilliant. All you need to do is tell me what languages they need to know, what markets, what layer of the stack. They'll be ready in 3 to 12 months. Just tell me. It's like ordering a pizza. They are desperate for jobs. AI has nuked the especially entry-level job market, and I'm hell-bent on getting as many of them hired as possible. So please, please, please reach out if you're watching this. I will gladly personally train them and send them to you when they're ready for graduation.
Yeah, it's good to have like good references and hands-on experience with not like production software, but with realistic market data and realistic infrastructure, and with your expertise working and CME and have being exposed to like trading side, exchange side. So this is great, and definitely I trust that your students that are coming out of your course are going to be prepared to face the challenges of the trading industry for sure. Yeah.
That's the job mandate. So thank you very much again. I'm honored to have this opportunity.
Yeah, thanks a lot, and thank you everyone for watching, and looking forward to see you in the next episode of Quants Worth Following. Bye bye.